Okay, here's lesson 4. I'm trying some new software, so bear with me if I make some mistakes. First of all, this is from Algebra 2 1.4, which of course comes after their 1.3, and I've been splitting up their 1.3 to go with the geometry on different days for different reasons. So these first warm-ups actually are beyond some of the stuff we've actually done, because it relies on some stuff like stretching in 1.3 that we haven't really like some of the stuff we haven't really learned yet. So let's not worry about that right now. But we can do part of warm-up 2, which is there's been some transformations that have happened, and write the new equation for this graph. Fx is transformed without using any reflections or dilations. Dilations is what we would be doing in the 1.3 that we haven't done yet. But it's saying it's not using any dilation, so that's good. And also no reflections. So the only thing we have, I don't know if you've heard me say this enough, this is one of those things that's been on lots of the materials, and I keep circling each time. I'm kind of repeating that paragraph about reflections, stretch, translate in that order. This one doesn't have any reflections, and it doesn't have any stretches, so the only thing this could possibly have is some translations. Okay, great. So this thing is just going to kind of slide around somewhere. Oh, I can use this kind of pointer thing. You follow that? This is just going to kind of slide that way or slide that way. Again, new software, new features. All right, so this maximum is going to be at negative 2, 0. Maximum. I can rotate. Oh, that's fun. Didn't know I could do that. All right, negative 2, 0 is supposed to be the new location of this maximum. So it looks like this whole thing just kind of has to do that. So if it has to be a translation. You know, the point that was here at the maximum has to become this new maximum point. Oh, sorry, negative 2, 0. Negative 2, 0. I did that wrong. Negative 2, 0. This point that was the maximum has to go to negative 2, 0. So that's the translation we need. That translation looks like it's going 2 backwards that way and 4 down like that. So to write this as a new function, I have to do f of the negative 2, the negative 4 at the end is the easy part. The hard part is the part in the middle. We have to do x plus 2. I think that's it. Okay, great. The other warm-up we can actually do is this one. For what value, and this is kind of like an old news one, but still, it's going to be helpful for today. What values of x is f of x greater than 0? F of x is this one. Be careful, there are 2 graphs on this page. It looks like it's greater than 0. Whoops. From negative infinity up to whatever this point is. I don't know, negative 2.5. It's greater than or equal to, so I'm going to include that. I'm going to use commas here because it's in the domain. It's also greater than 0 from here to here, whatever those are. I don't know, 1.5 up to 7.6. Oh, this pencil operates differently. I got this thickness business going on that I'm not used to. All right, for what values is f of x greater than g of x? So that would be the areas in which f of x is kind of on top. So f of x is on top here, f of x is on top of g of x here. So those are the areas where I need to write the x domain, or the x kind of range here. So this is negative infinity up to negative 2, and it's greater than or equal to, so I'll use square bracket, and then from 3, positive 3 up to positive 8. And then where is it below? Well, it's everywhere else. So f of x is below, and it's strictly less than, so I'm going to use open brackets here. From negative 2 up to 3, and I guess that's it. Oh, no, from 8 onwards. 8 up to infinity. Okay, great. All right, turning page is different. Oh, yeah, hopefully the video will track that. All right, beginning of this one. These are super easy, the beginning of this thing here, so I'm just not even going to deal with this. This, I'm sure, is something you can do on your own. We are going to keep this video short, and we're just going to keep moving. All right, this whole lesson is about composition of functions, which kind of is old news because we did that when we were talking about inverses in the logs unit. So this is going to seem kind of easy. I think this video is going to be super short. Okay, f of x is 2x minus 1, and g of x is x squared plus 3. So yeah, you can figure out this pretty quickly, that f of 2 is 4 minus 1, which is 3. Whoops, I need a pencil. Is 3, and g of 2 is 4 plus 3, which is 7. Let's put the value x is negative 3 into the f function. We're going to put negative 3 in there. And then what's going to be, okay, let's do that first. That's going to be 2 times negative 3 minus 1, which is simply negative 6 minus 1, which is negative 7. That comes out as negative 7, and then here's the thing about what composition's about. It's about putting that straight into the next function, like linking these two things together. So we need to find g of negative 7, which is negative 7 squared plus 3, which is 49 plus 3, which is 52. Is that the end of this page already? I am flying. All right. Next page. All right. Yeah, sorry. It does turn pages kind of strange. Function composition is an operation whereby the output of one function is directly linked as the input of the next function. And we talk about stuff like f of g of x, or you can write f of g of x, either one. Oh, yeah, this rotation thing is freaking me out. If I put, f of g of x, that means g of x is the first input. I put something into g. Think about how you operate with parentheses. You put x into g first, and then that output goes into f. If you forget what this little thing means, I would say, think about writing it this way. I think that would help. Okay. And that's how we say it. So let's do one. And again, we did this in the log unit, so this should kind of feel like review. F of x is x squared minus blah, 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 and g of x is blah, blah, blah. Find f of g of 3. So let's do g of 3 first. And then that output we'll find the f of that. G of 3 is 2 times 3 minus 4, which is just 6 minus 4, which is 2. And then I need to find f of that. F of that is 4 minus 6 plus 2, which is 0. So when we're talking about this operation right here, we actually do g first, which, I don't know, hopefully doesn't surprise you too much. And then in this one, given these two things, actually find f of g of x. So this is a lot more generic than just that last one up there. The one up here in example 3 was put in 3 into g and then put that result into f, and we're going to get one number. This is put x into g and then put that, kind of like for infinite cases, put that into f. Well, this is the same as, let me just write this, f of g of x, which, okay, fine, but that's f of, what's g of x? X squared. You can think of it that way. So we're going to put x squared in as the input to f of x. F of x makes x into x minus 3. We're trying to find f of x squared. All that does is take x squared and put it into this function. So this is x squared minus 3. I think we're done. This is a pretty simple one. We will do the backwards version of that in class, just to give us something to do in class. And we will compare them because we'll have those both done. I'm really flying. We're almost done. Okay, this is weird. In this one, see that line down there? I tried to put a line like, here's where the video stops. And the line doesn't move. Anyway, we'll talk about that in class. Ignore that red line. I can't get to move. Consider these two functions. Just do another one. G of f of negative 1 means we're going to find f of negative 1 first. F of negative 1 is 3 times negative 1 minus 1, which is negative 3 minus 1, which is negative 4. And so I need to find g of negative 4, which is just negative 4 squared plus 2 times negative 4 plus 5. Oh my gosh, 16 minus 8 plus 5, which is 13, if I did that right. Yeah. And then we'll do the rest of them in class. Again, this is just about linking one function to the next, and it's not too bad. Find the equation for g of f of x. Again, I can't get rid of that red line. G of f of x. So I need to use basically this structure of g, but instead of, where it says x, and you might remember this from when we did logs, I'm going to stick this in everywhere it says x. G of x takes the input x and does this to it. But now I want to find g of this as an input, g of f of x. So we're going to do 3x minus 1 squared plus 2 times 3x minus 1 plus 5. That's it. Should I simplify this? I guess so. We can talk in class about how important it is to simplify. Sometimes I want you to simplify these things, sometimes I don't. This video seems so short. Let's just do this for fun. All right, so this is 9x squared. I gotta do 3 times 1 times 2 plus, no, minus 6x plus 1 plus 6x minus 2 plus 5. Combine like terms. Oh yeah, that was in the worksheety part of the previous page. Ooh, those x's cancel. That's kind of cool. Plus 4 Oh, that's kind of fun. And I think that's the end of this video. I think that's the end of what I need to talk about. That's where that red line was supposed to go. Okay, great. See you in class.